So I'll take it away, guys.
Okay, good. Sure glad that thing's working. I tell you that. Hopefully, I'll be able to manage this. So, anyway, as you can see, that's a picture of what it is. A Focke-Wulf 190 is a German fighter plane from World War II, and I just happened to have one that was a replica. So, I found the shortcomings of a war aircraft, and now we're trying to make it a better airplane than it ever was. And so, that's kind of what this talk will be, and how we got to where we are. So we called it the ButcherBird's what a Focke-Wulf 190 was called in World War II, kind of like you had P-51 Mustangs. Well, it was a nasty little bird airplane that the Germans made that was really good. And so the Allied guys didn't like it because it was initially a really good fighter for the Germans. So here it is. We're creating a scaled composite Focke-Wulf 190. There are none in the world that I know of. AirVenture kind of go with this. And a little bit, just so you guys know, this is a rerun of a little bit of last year because there'll be some new people here. We're going to present at Oshkosh, so just kind of so you'll see how this begins. And as you can see, this is AirVenture 2018. There's a picture of some of our EAA Chapter 34 guys with our shirts on that are the tie-dye shirts. And I'm watching Russ Emanis do a composites class. Happened to find, and he was teaching how to do composites. So we were at this composites class numerous times, because I was seeing a lot of interesting things that were going through my mind.
We built 2 airframes at that one.
Oh yeah, yeah. You at 2018, is that when you?
No, yeah, 2018 we did 2 airplanes, yeah. 2 complete airframes.
So he's building, they're building things right there while they're demonstrating. That tells you how good his systems are. He can build the composite stuff right there under a tent at Oshkosh. Yes.
How many other people do that? Build an airplane while they're there, actually.
In composites? Nobody.
Yeah, nobody. So anyway, you kind of see, here's some pictures of how he's doing it. This is a satellite dish or a dish of some kind, and he's just showing you how they infuse this mold with the resin at the exact right ratio into the fiberglass or the composite material that's there, and it gets exact perfect saturation. There are no air bubbles, there are no voids, no anything. So it's a great way to do it. It's under vacuum and it's super tight. Okay, so anyway, here's fate brought us together. It was kind of interesting. I found out we live 8 miles from each other. We were up there talking. I kept talking to him all the time because I kept thinking, man, I can see, in my mind, things are going on because I'm figuring out this could fix this war aircraft replica company if they would do something like this. So we live 8 miles from each other. We're up at Oshkosh, and he lives over here in Keller, and I live in Colleyville, and I'm telling you, it's close. We both are into airplanes. We both have big ideas and dreams. And that's one of his that he's built, or it's actually partially built.
Yeah.
Right, that's the Odyssey. And just so you know, he was doing this in his driveway, from his garage in his driveway. So he was able to, this is showing a basic builder how they could potentially create their own composite airplane.
How to shape it.
Yeah, how to shape it. So he gets the shaping done. This is going to be the fuselage. I'm going to go a little quick through here till we can get to the stuff for this year. Creating the mold. I'm not sure. Some of these are videos. I have to kind of be careful. Or?
Did it go off? No,
nope.
It's up there.
It's not moving forward. Let me see if I... Oh, okay, well then... Okay, there we go. Creating the mold. Anyway, you can see here we are in a driveway with cars all around. And the first thing we did was create the plug. And then in his driveway, we created the green part too, right?
The molds.
That was the mold. The green gel coat that's there. That's the mold. And you can see, if you look on the upper right, you can see how smooth and perfect that is, because what he had was a perfect plug. The plug was awesome. And so it made the mold awesome.
My neighbors all came down to see what we were doing. They thought it was just great that we were doing it in the driveway.
Yeah, so that's where. So this is kind of what it looks like when you do this. He's creating the part. Oh, there it goes. Okay. Now we're up at Oshkosh with his mold that he made in his driveway, and this just shows you a picture of the infusing resin into the mold under a vacuum. So that when that vacuum pulls down, it is tight. And Oh my gosh. Okay, so I don't know this stuff. Okay, so
So those are the parts that came out of the molds that we made in the driveway.
right, and so that was a carbon fiber part. Weighs nothing. It has a core on it. What was it? 2-core 2.
Yeah.
Weighs nothing and it doesn't bend. So it's super strong. And so once again, I can see these things. You know how interesting this is for what things I want to do. So as I mentioned, it's light and strong. Guess I need to find out where we are.
Wait, it's
Okay.
trying to find itself.
Okay.
I don't know what's on that picture.
I don't know. There's a picture probably loading a picture right now.
Yeah, it's got a load everything logo.
Okay. I would jump ahead if it would let me, but it doesn't seem to even let me do that. Tell you a story? The what story? The Tulsa story?
How did you get into aviation, Chris?
Oh,
He flew into it.
I flew into aviation. No, I think my dad was always a model builder and we flew control line planes. And so I liked it from that. And then of course I made plastic models and hung them all over my ceiling with fire and stuff coming out of them and crashed a few, like throw them around. And then,
Will it change?
I don't know. Can I make it go forward? It won't let me do that either. If I hit escape, it's liable to jump out of the whole thing.
And
Okay.
now shift down. Just shift down. Right here.
Okay.
There you go.
Okay, so then I do, oh wait, then I got it. This thing, see, I'm used to touch, can I touch your screen? Okay. Okay, so anyway, so what we ended up doing is making this part up at Oshkosh, and then later on, probably the next year, we bought the rights to Starlight, and that's this little airplane right here. And we have one of those at my hangar right now that's needing to be built. But another interesting thing that Chris Sims notices about this is virtually the exact same size as what I want to do. So there's a lot of, and this tells me how heavy things are and how strong things are. But Russ bought this thing and owns the company, has the molds, and you might be able to talk about that a little bit, if things you're wanting to do with it quickly.
Yeah, so I bought it from a good friend of mine who bought it from Mark Brown. He was going to put them into production, but he was terrified of liability, so he just kind of held on to it. He turned 75 and he called me and said, Russ, you still want it? I'm like, I'll take it. So I got the tooling, brought it back here. The intention was to have a flying aircraft at Oshkosh 2 years ago.
Yeah.
And so we sold the first kit, and the builder first got a divorce, and so that kind of wrecked everything. And then after he got better from the divorce, he got a girlfriend, and that really slowed the airplane project down.
That basically killed it.
Yeah, and then after that, then his mom passed away, so that crashed it even further. And so now we have a derelict kit, basically. I can't build it for him. So we're going to, on that particular kit, we're going to sell it to somebody who wants to build an airplane at a really deep, deep discount. I really would like to get one of them, a new one, up and flying. I can't. I put $380,000 in the other project, and I would have to live in this one if I put any more money in it. So I need a customer for the aircraft. We may take this one to Oshkosh this year with us.
Right, and right now there's a fuselage. All the parts are there.
But what's important to note here is that these are composite aircraft, whether it's fiberglass or whether it's carbon fiber. Generally speaking, they're all made the same way. They're either resin infused, or they are wet layup and vacuum bagged. Nobody can really afford autoclaves for home-built aircraft, so that's generally how it's done. And my experience in composites goes all the way back to 9 years old, fixing surfboards, all the way to Lockheed Martin on the most advanced composites on the face of the earth. So it's been really fun to get to this point where we can make really great stuff without it costing an arm and a leg. So this translates very directly into the ButcherBird and what we're trying to achieve there. So a lot of the engineering that was done on the Starlight, it took me forever to go back through and verify because it was all done in 1982. But we went back and verified that. And one of the things that we did was we changed the wood spars to composite spars. and then we tested them to failure.
And that's on here.
Okay, good deal.
You'll see it.
Yeah.
So I don't know how I got this little thing up on the screen, but but anyway, another thing about that, that's a fast little airplane. It can be like 150 mile an hour, depending on the power you put in there. Or with a low power engine, like 35 or 40 horsepower, it'd still make 100 miles an hour nearly. So a couple of gallons an hour. So, all right, so Starlight, I'm just showing you, here's how they built this. That one has the composite spar, and it has some foam ribs, and we can basically do a lot of the things with the this ButcherBird airplane. We've probably changed some of the foam ribs, might be some carbon fiber ribs, and this elevator, or actually this is the horizontal stabilizer, is exactly the same size as my ButcherBird thing. So everything is almost dead on within an inch or so.
Well, when we built this one that we've got, it still calculates out to hit 254 pounds.
Oh, you're talking about, yeah, the weight of the airplane.
Yeah.
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 So it becomes still an ultralight. All right, so breaking the Starlight spar, if it'll play. There it goes. And this is really kind of not the greatest videoing, but you can see kind of what's going on. We have this spar in a truss that's got a hydraulic ram on it that's going to start pushing it very hard.
It's pulling down
or
now.
pulling down, yeah. So, and can't hear the volume, but we're just talking. So we're cranking this ram, and we're watching the pressure on the gauge, and that pressure.
We translated into pounds per.
Yeah.
So basically, when I did the math on the spar, the Starlight had a 3G wood spar in it, and I wanted a 6G spar in it.
I don't know what to do.
So I did the math on the spar, I did the laminate schedules, calculated all that out. We took the time, we built it, and then we built the set to break, and we broke. I was off by 3% to get to my ultimate loading. So we went back and made adjustments to that, and so now we're a true 6G with some extra in there. So a lot of the things that we do with that will go into the ButcherBird and how we create his spars and his wing skins and stuff like that. No, it's plus 6 minus 4. Yeah, but when we actually sell kits, I will never post that. Never.
Because somebody will try to figure it out. I wonder if that's where it really breaks, right? So,
but I need to know for sure where they fail. Yeah.
Yeah. So we're just.
I even predicted the exact failure point.
So I'm saying something, you can't hear it. I'm watching the pressure. Suddenly the pressure dropped on the ram. And that's happening is it's going plastic, I guess. And then
broke.
That's where it broke. You heard a little crack, and it breaks in compression.
Yes.
Not in tension.
Yeah.
That was kind of weird. I was looking at it like, that's kind of strange. Why did it do that? That's because Russ will tell you carbon fiber can't take compression.
Well, carbon fiber is not a good compressive material. Yeah. No, we didn't have any buckling. We actually had a clean shear on the failure of the upper where it came together, where it actually did that and then caused an immediate perfect shear right down where hard point to core met. It is where it sheared exactly where I thought it would.
So you had a core and then a solid laminate, and it broke at that intersection?
Yeah, it broke at that intersection. So, but I predicted that's where it was going to break, which is fine. You can do it like that. You need to have more fiberglass in your upper spar cap than carbon. What you really need to do. So,
yeah. And if the spar is bonded to the skin, that's just extra.
It's additional.
That'll be additional. So anyway, noting this, ButcherBird will have a 7,500 pound spar break. So it'll be like 7.5 Gs. I figured that's no fun for anybody. So that's 2023. Of course, I kept talking. This is after COVID and all this. I was talking about this kind of stuff. His shop had room for the project. I was willing to allow my airplane to be the plug, and he agreed it was doable. We went to an AirVenture 23 would be our venue, and I got the airplane to the shop. And I kind of started doodling around and making patches, as you can kind of tell, something I know how to do. I can't do the composites, but I can do this. The purpose is to explore the sport aircraft warbird replica market. There's only P-51s. There's every kind of P-51 you can have, and there's nothing for them to shoot down. And I felt terrible about that. So I don't care who shoots at me, but bottom line, there's nobody doing that. So why not? And I happen to have it. Goals are going to be to make it lightweight, like 550 pounds. War aircraft replica in their brochures always said 600 pounds. None of them were 600 pounds. They were always 750 to 800, way overweight. We're going to be able to hit 550 or pretty close. Fast build, like 500 hours. I was going through the kit planes, airplane directory. There's no kit planes at all that are 500 hours unless it's a legal eagle or something like that. That P-51, that's the composite one, the SW-P-51 is like 800 hours, and it's kind of built like this. We think we can build this in 500, maybe 400. It's going to be roomier. It's a small airplane, but it's going to be roomier because it's monocoque. There's not going to be any wood frame anymore. It's gone. It's just going to be the skin. It's going to be pretty fast. Figure probably about 170 cruise, maybe 180 or so for full power if you want to go that fast. That UL power. The 350 IS, 130 horsepower. It's going to gain 40 horsepower nearly, or 35 horsepower.
And lose weight.
And lose a lot of weight. Complete kit. Unlike the way the wars are in a lot of kits, you're going to be able to get everything, including the engine and the avionics built, if you want it that way. Simple systems. Everything's got to work. It's got to be simple. It's also got to be work. You got to be able to work on it, do maintenance. It's got to be attractive. Got to have a price that can be affordable, and it's going to have great flight characteristics. It's well known the war aircraft replica FW-190 was one of the best flying ones that they had. So a lot of people said this thing flies good. So I've had a lot of people tell me that are flying them. So we made a display model last year, kind of showing it with the molds that we made, and just to show we could kind of do it. And we did that in 2.5 months. That's pretty fast. Let's see. It may be going just slow there.
What kind of prop are you going to use?
Called a prop. It'll be a 3-bladed prop.
So is it fixed?
Probably, unless I need weight on the front. I don't know if it might be, but
It's catching up.
there's a potential for me to need weight forward because this engine is 35 or 40 pounds lighter. But we're going to lose a lot of weight in the back too. Lots. These wood airplanes are super heavy at the back. So it may all balance out, but I started thinking, well, I may have to put a constant speed prop on, and that'd move another 15 pounds out on the front, and that would probably fix anything. Okay, so here I drag my airplane over there. We flip it over on its back. We start making, this is how we had to do it for this particular, creating the mold. Had to make flanges, had to do all kinds of stuff.
That was me with a beard and 30 pounds heavier.
Yeah, really. So you guys kind of, flangings extend, it took a long time. Oh, and here yeah, okay.
I'll tell you what, when we looked at this airplane, it was horrible. In terms of the surface, it was horrible. I mean, it was
oh, I can't, yeah. This just shows us laying the fiberglass on the mold.
well, right here shows you building the flanges so you can flange them. And then over there, they're putting fiberglass down. And all of this was down and dirty old school because of budget.
Yeah.
He squeaks when he walks, so we had to.
Sure.
But we did it in 2 months. We got all those molds made and his prototype.
Yeah, and then we have to weld it all up with framing to keep it from moving. I'm going to go a little quicker. The mold. There's the mold that we pulled the bottom out, or the fuselage off, and we learned a lot from this one. We'll talk about that in a minute. How it got, yeah. So once we lifted it off, once we got it out of the bottom mold, we have to put it back. So this is kind of interesting. This thing's pretty heavy. And so it's out of the mold, but we want to put it back in the mold to kind of to help the mold. It helps the mold, I guess, like that. So I can't remember why.
Yeah, well, we had to put it back in the mold so we could mold the top of it.
Oh yeah, mold the top. That's right.
And the German word for what we're fixing to do is human loading.
Human loading.
Human loading.
Human loading. Yeah.
Yeah, and that was a gyration there.
Yeah, we got a lot of bodies out there. You can see Michael McCorkle's there.
Michael lifted with his belly.
Yeah, Michael did it. He's a big guy. So he's got it over there. It's right now the front of the airplane is higher because it's in this rotisserie. So we had to come over and release it, and then it just drops in and fits perfectly as it should, right?
Yeah.
This will be a lot easier with the new airplane, right?
Oh, yeah.
It won't weigh anything because I'm carrying wood, foam, fiberglass with extra resin, and the foam, Russ says, absorbs moisture.
Yeah, the urethane does.
The urethane foam. So
there's no telling how much that airplane weighs. I mean,
I can weigh it.
It's heavy.
And there we are. We made it. Everybody's congratulating
and so
themselves.
all those flanges we put on, that allows us to make the other molds so that the flanges mate with those flanges. So you can put those together and get your part lines correct.
Okay, and I kind of walk around. You can kind of see it there. And
we got a lot of pushback and flack from the swastika on there. Swastika.
The company plane will not have that, but builders can do whatever they want.
Well, the EAA German aircraft have the original design with the swastika on there.
All I know is mine will be a captured one. It'll have a star or something on it. You know, maybe whatever the British had. I don't know. We were showing how we built this thing. It's taking a long time to load it, but you end up, here's the top half getting done. We put a coating on it, and then we started putting the fiberglass on it.
Yeah, so you got little locators there so the molds go back together, index correctly.
Yeah.
And then what you're looking at is PVA was sprayed on there, and that's actually after the mold came off that side. You can see
it is? Okay, yeah. So,
no, this was just a wet layup, fiberglass wet layup to make the molds.
Then we started doing the cowls, drawing the template. And I'm kind of showing you this because this is all you'd have to do. You had some idea, mating and we were hot gluing this thing. We went through a ton. I've never hot glued hardly anything until last year. And then last year I was going through stick after stick after stick. We were buying them by the bags. And so that's what we do. And then you build a flange. And
so let's go back on.
Oh, well, don't ask. I can't do that.
Okay. So anyway, that's what came out of the mold that we made off of his airplane.
That's today.
Right? Yeah. Well, this was made yesterday.
Oh, yeah.
And it came out today. You can see, where it's peel plied, and I mean it's really, really lightweight. Don't cut yourself because it's not trimmed up all the way.
Yeah, we should have brought the other molds. And it's got core in it too.
Yeah, it does. This is cored from, you can see the core lines here, all the way around that. No core in the cheek. It was too complex to.
Oh, and then so what we were learning, we had tons of trouble. This is making these molds better. So we ended up filling all of our holes in because we had it was leak city with these things. We could not stop leaks because we're under vacuum, and when you get leaks, it does you don't flow the resin as well, and I guess it doesn't go all the way through.
Well, we had to go around. The actual airplane had all this stuff that we had to actually flange off.
Right.
And so it created all these little windows that were almost impossible to seal with tacky tape. It was just, hard.
So what we're doing, making them better, we're just filling all the holes in, like the wheel wells. We're just put a piece of wood in there, and then we glassed over that stuff. And then we were truing the surface. We went through a bunch of Bondo and everything, and then here's our guy. He's polishing the molds. And there's a lot of polishing.
There's a lot of everything.
And then we start laying this is a couple of weeks ago, or we started laying new carbon fiber into these molds, and this is the top. You can kind of see the two where the gun barrels would kind of lay out right through the top there. This is upside down, of course. Top cowl, and here's the bottom. Now, this was a different way to do the bottom that you did.
Yeah, because it's summertime. The back shop back there with these molds, the rest of the shop's air conditioned, but the back shop's not. It's hot. and it'll get out of control. And so we had some problems getting through a structural material that we use. So what we did was a wet layup on the skins just to ensure that we had good contact with all of the primer that was sprayed into the molds. And so now when you see the next pictures, all that was peeled and then new materials laid on that, ready to be.
Well, this one I just switched. I went on. So here's kind of what this one we're not using yet, but I'm just kind of showing you. This was because we had some dry spots, which he can fix. There's a dry spot there. You kind of see them, but this is you can see the dry spots. And what he'll do is he'll put tacky tape around that, and we'll vacuum that and suck and put the resin into those areas. Okay, and then we learned about the wonders of CAD, which is computer-aided design, which I am into now. I don't do it, but this is awesome. So I hire a guy that can do this, and a critical part is the landing gear going up and down and fitting. That's a big deal on airplanes that do that. So I give him the data. Here's how he gets it all drawn into CAD. And we finally figure out some angles. This is rough still. We have a few more iterations to do. But he's saying now the wheels are fitting. Everything's fitting into the wheel well. And let's see if this works. I'm afraid to hit the button again. It might, yeah.
Hit it.
Well, no. I've had trouble all day long with this thing.
Go.
Watch this. Oh, yeah. That's awesome. So he's put this together, and now he's showing it going up and down. This is the front side of the spar. My plan is to use a linear motor because those things are amazing what they can do. And so he can check everything's working on it. And then here's the back side of the spar. You can kind of see what it does there. And there's a little gas assist hold down strut. It's on the back up there on the, yeah, you can see it. And Focke-Wulf's really had that, although it's on the front. I'm going to try to convince him to put it on the front, and that helped the gear to stay down because they actually had electric motors. And another thing I like, this is effectively an electric motor, so it kind of makes it correct. So then you get to what you're going to do for a panel. My plan is going to be to have this, something like this. It's going to be simple, clean, it's going to work. I've already figured out I want all the switches on the right because, you know, when you're starting the engine, that's when you can manipulate those. When you're, you know, your throttle, of course, will be over here on the left. The gear handle's on the left. The radio is on the left. You can reach up and tune the radio. And this little MGL MX1 will have the engine instruments, everything in it. And if you buy it like this for, let's say it's 11 grand, you buy the whole panel, it'll have ADS-B, and it'll have ADS-B. It'll have everything on it, and all you'll do is you'll just put your 4 screws into your firewall and plug that thing in, and maybe you have to hook up some lights and some other things. Well, let's say it takes 2 hours max, and your avionics are done. And you've plugged your engine, from your engine cannon plugs, you plug that in also the back, so you have engine instruments.
For the kits, MGL has committed to make the actual harnesses.
Right, they'll do that too.
Yeah, so.
Yeah, so that's the bottom line. It's going to be more about building and flying an airplane, not just the journey of years and years of labor to finally lose interest, have a health problem or whatever, and then sell that thing. This is going to be lightning fast. Next steps after Oshkosh. I had this earlier today. This said before Oshkosh, but things get in the way. We're going to scan the fuselage and create a CAD model of the whole fuselage, and that way our CAD guy will be able to locate all these bulkheads. And we're only going to need, what, 6 bulkheads?
If that, yeah.
Maybe 6. You don't need a lot because the structure of the skin is going to carry a lot of the load. The bulkheads are going to basically be there for us to locate some of our metal hardware parts. And, of course, at the front, we're going to need bulkheads to take the torque and the weight and stuff of the engine. And there it is. I'm locating the bulkheads for the seat. The seat will also become a part of the bulkhead system too. And we've got to have a tail wheel. That's going to be stronger. There's going to be several bulkheads where the tail wheel area is. And we're going to have, of course, mate all the hardware. We're going to have to create the firewall with hard points for the engine. And UL Power's already told me once we get that located relatively close, they'll build the motor mount for me. They want to sell the motor. They got a dude, I'm sure, that sits there and just puts the sticks in the computer and puts them where they got to be, and then boom, you got your engine on there. I'm going to put an aluminum header fuel tank, so it's going to work like a real Focke-Wulf. You're going to raise the front of the top of the motor, or top of the cowl. Right, well, it's in front of the windscreen, and right there will be the fuel tank. It won't leak. That's another problem we had: leaky fuel tanks and hard to get them out. I spent hours trying to get this out. We're going to make it easy. You're just going to open that thing, probably be 4 bolts there, unscrew those. If you got to get the tank out, you pull the tank out. And guess what else you see right below the tank? You got rudder pedals, brakes, everything right there. So if you need to work on something, piece of cake.
How many gallons?
13 or 14, I'm getting. That's what they usually are. That'll give me about 2 hours, about 300 miles. Gonna have to create, and see, these are things I have to do once we get a little bit past Oshkosh. I'm gonna create hardware lists for the different assemblies. We're gonna figure out this retraction system, because I have to do metal. I mean, we have to make this stuff out of metal, obviously, and the spar design, we gotta get that all done. We're gonna probably build a mock-up of that and test that with like a wooden spar type thing. Yeah, you can get the landing gear and get the. So we've mocked it up with printed plastic, and this is very Focke-Wulfy. This is the way they were, believe it or not. They kind of were like this, and not this part. But so we're trying to make it look right as a bonus. But yeah, so that's going to be our landing gear, and and you can get the tire and the wheel and all that stuff too if you want for me. And so we got to do all this, get the retraction system done, and I'm kind of liking this retraction system because really I'm just almost cutting or stamping out metal parts from sheet metal to make to make the parts. So yeah, this is a real aircraft wheel. The war aircraft used go-kart tires and go-kart wheels. So,
my concern when I saw this was the size of it.
Yeah,
and that's what a lot of this CAD work did. Was it we had to move some stuff around in order to get this tucked up in that wing.
Yeah. No, it's a wheel that fits. If I could have got a skinnier wheel, I would have. But that's as skinny as they are. That's basically a 3.5 by 4 by 6 inch wheel or something. But that's a real aircraft wheel and real aircraft brake. It's a Matco system, and I can get that real easy. Instrument panel, of course, I mentioned simple, light, and powerful. Do everything you want. It only weighs about 3 pounds. These are all my weight savings. This is how we're going to do the weight. And my goal, I don't see a reason I can't if I just, if I can keep feeding the beast, we can have a flying prototype, because we don't have much to do. I got all the hardware for at least one. I'm just pulling it off my old war aircraft stuff I've got. And we may have the only thing that's going to be different is the landing gear system, but we have a lot of the metal parts already. Once again, volunteers are needed. I need CAD guys, graphics guys. If you're that kind of person, ideas. You guys have a good idea, I'm totally willing to listen to that stuff, of course. And here I am talking about that UL Power. This thing is, like I said, about 30 or 40 pounds lighter than a Continental 0200. It also is fuel injected, has FADEC, has electronic ignition. It's 4 inches shorter than a Continental 0200. It's also thinner, top to bottom. It's just an amazing thing. It's completely machined. Everything's machined. There is no cast parts on that one. So that's probably where they do it. It's a pretty expensive motor, but I want to have, at least for the prototype, I want to have the bigger motor. You get a little bit smaller motor in that, but I want to put that engine will be about 30 grand. Talking about airplanes. So if you bought a Lycoming, it'd be 50 grand. But it'd be certified. But
even the road taxes.
And the road taxes are about 40 if you buy certainly if you buy the 912 the 916 turbo is expensive too.
So Chris, that's the engine walk.
Right. I know. I like that.
1,500 hours.
Yeah. Okay, then possibilities. We were talking about this last year. We don't see a reason why we couldn't turn this into it, huh? What now? Oh, I just picked it. I've talked to him a bunch. I mean, I could get a road tax, I guess. Just this is air cooled. I don't have to have the cooling. I mean, if somebody else wants to buy it and build, if they just want to buy just the kit, you don't have to buy the engine I want. But I don't know what that does to the weight and balance. I won't know any of that stuff. But I'm sure it'll be. They're comparable in weight. They're all around 180 pounds. A Rotax or a UL Power. It's only when you get to the certified engines that you kind of wildly go above those numbers. So we think we can build an ultralight ButcherBird with his. We wouldn't use we'd use less material and all that, and we'd have a chrome moly substructure in there, and you could have that. I mean, an ultralight, 250 something pounds. Put a small motor on it. It probably, maybe
the wings would look.
They'd have to be bigger. But you couldn't do it with that. 77 square feet. We can make skins for wood stage war projects. Someone here could use that. Interchangeable parts. If you need another, like this landing gear, if you have a problem with the landing gear, you need another part or something for it. This is going to be easy for us to do. This was last year. It's kind of fun to think about. I doubt that's going to happen, unless you guys want one.
You got plans for that B40?
I do have the plans. You want to buy them?
Maybe.
Okay. I do have a YouTube channel. I have a Facebook channel. I'm maybe going to have a website. I'm kind of guessing that nobody's using that name for a website. If my IT guy will get that to me, I'll have that. So that's kind of where we are right now. Like I said, I got some show and tell a little bit over there, and he's been showing it. There's a mock-up of the instrument panel. We have some of our parts that we printed out of carbon fiber over there, and that's what we'll try to have for Oshkosh, because that's strong enough to hold the airplane without somebody riding in it or something, and so we can roll it around at the airport.
So for me, with this project, I tried to emphasize to Chris originally how critical it was going to be to get that fuselage digitized, scanned and digitized, because we've molded it, but we don't have any internal structure actually modeled to that yet. So I have a scanner digitizer, so we are going to digitize that, give it to Bob, the CAD guy, and then we can start finalizing locations of things and stiffeners and run finite element analysis and all of that good stuff once we get the fuselage actually digitized.
And he's actually done some finite element analysis on the landing gear. He's been looking at these things made out of I can't remember, 61, whatever the aluminum is.
6061.
6061, and he's already showing me where it's showing the stresses are. So it's kind of neat. I was looking at that.
So it's a big challenge to do something like this, but the end result needs to be where the builder doesn't have that challenge at all.
Yeah.
And some of the older composite kits, especially the very easies, the long easies, and all those all fiberglass kits, guys just stopped. It was just killing them. They couldn't get fairness. They hated working with the fiberglass. Even the RV guys on the wingtips and their fairings and stuff like that, they hated working on that because it was a lot of sanding and filling and fairing.
Around.
So we just intend to create parts that go together properly,
carbon fiber printed,
with user-friendly bond lines. And as few parts as possible.
How long did it take?
I don't know.
That's an 8-hour print, but it's 100% infill. We run 3 printers. Yes, sir?
Huh? What about the canopy? Can't hear you. It'll be like that.
It'll look like that.
It's going to be mine. We're going to try it. We talk about it. We're going to try
to raise it just a little.
I'm going to try to put a 1/4 of an inch here and there just to get a little bit more headroom.
So when I got the Starlight, I'm 5'11", and at 5'11" in the original airplane, I actually have the original airplane Mark Brown built, the very first Starlight. It's up in the rafters. But when you sit in there at 5'11", when I closed the canopy, it was on my head.
I lowered my seat bottom so my headphones wouldn't touch
So we basically digitized it and reshaped it, worked on the ergonomics, I can get a 6'3" guy in there now.
His head clears.
Yes, and it had to do with the contouring of the bottom of the seat. You know, the way they did it was, and the way that this is done, the way the ButcherBird's done is it's more blocky.
It's awful.
And so
For that.
the inside of this airplane is cavernous. Even though when you look at the war, it seems so tiny and small. When you look at the mock-up, it's cavernous. I mean, you're going to have a lot of space in there.
Because we lost an inch. You know, the wood, the framing is an inch.
Well, but it goes this way.
Yeah, and it's a box, and
Yeah.
that's gone.
And
So
all
we're gonna gain
and so
room.
the fuselage goes
And
this
we're
way.
not going to have a blocky seat. We're going to have a seat that can
It's
give us a little bit of curve, so you can get a taller man in there. Hopefully, I'll have or a woman. You know, you can have a parachute maybe blocked out there for it, should you need it. If you don't want to wear the parachute because you're tall, you just gained another inch. So things like that. And if we can blow the canopy just an eighth or a quarter of an inch and make it look okay. I don't want it to be a cartoon, but if it'll look okay, headroom's what killed me. I hated it because I couldn't wear a headset because basically you went dink, dink, you know, and that's it. And you really, when you're going down, you can't see good. You want to be able to move your head so you can kind of get your eyeballs adjusted and get your perspective right for leaning. Well, they were narrow anyway, but that's a real one. That's not mine. Mine's worse. So, but we're going to make it as good as we can make it. Yes, sir. Slide. They're slider. They slid, so it'll slide straight back. Yes, sir.
What about the adjustment on the pedals?
I think I think that'll be like a builder preference. If you're a tall guy, but I don't know how far you can go forward. We talked a little bit about that, but this prototype's just I got to get something that can fly.
ideally what we'll do with that is when we produce the parts is we'll bond in rails.
Okay.
And
You can set it where you want it.
Maybe have a spot, maybe have 2 spots or something.
Yeah. Now, one of the other things that we're going to do with Chris is, like we did with the Odyssey and with the Starlight, is I built fixtures for everything critical, all critical alignment. So like your wing spar locations, your vertical stabilizer spars, horizontal stabilizer spars, any of your spar box, any of that stuff that's critical, we're not going to let the builder do. We don't want the builder to do that. We want to put those in a fixture, bond them in place so that all they need to do is like a Revell, just start putting it together. So
Right.
And it's not going to cost that much more to get all of that done. When I talk to Starlight builders, especially the guys that have bought Starlights after somebody already started it, I was shocked because they have twisted tails. Their horizontals aren't perfectly in line with each other. I mean, there's just things that could be corrected with very simple fixtures. So that's what we're going to do with Chris's airplane. We're going to fixture all that stuff.
And it's all laser located.
Yeah.
He's got a gantry lays across the top of the frame, right down the middle, and he's got this laser that draws lines all across it. So it's going to be very accurate. Yes, sir.
How much to get into the Starlight that you have? Build it, finish it.
I'm sorry.
How much to get into the Starlight that you have? To finish it and build it, and can it be built at your shop? So if I wanted to build and finish the Starlight, what's the estimated cost to get into it, finish it,
Well,
and finish it at your shop?
I think it's going to cost $20,000. Yes, you can build it in my shop. 10,000 of that will go to the original buyer. All of the parts for the Starlight are done. Spars are done, ribs are done, wing skids are done, wing tips are done, landing gear, brakes, axles, seat. I even have a parachute I'll throw in, one of those.
Oh, ballistic?
Yeah, I've got a ballistic chute for it. We've got the engine, we've got the prop, we've got the reduction drive.
So that's $20,000 with the engine?
Yep.
Wow.
But this time it's going to be with the caveat that you got to finish it before Oshkosh gets here next year. Yeah.
Comes with a time requirement.
Yeah, for sure. For sure.
Yeah, we didn't do that, or he didn't do that last time, and that kind of bit him because the girlfriend problems and stuff like that.
That's called induced drag.
That's induced drag. Yeah. So, I guess I bumped something.
But the engine's brand new, the prop's brand new, the hub's brand new, the reduction drive's brand new, the wheels, brakes, axles is all brand new. Everything's brand spanking new. And
that's a tried and true design.
it absolutely.
It's a tail wheel. Tail wheel.
And we molded all of the leading edges of the wing. Every one of them.
I don't have that picture.
Yeah. Whereas on the original ones, they were the wood spars, foam ribs, wood skins with glass over the wood skins, and none of the guys ever got their leading edges right on. So we just straightened them out and just made molds of the leading edges. So if a guy wanted to, at the root, it's over a foot thick, deep. You could actually fuel in both sides if you wanted to, not run a header tank.
It has how many gallons? 5?
At least.
I mean,
Yeah.
okay.
Yeah.
And then with that,
But if you're interested in that, let me know. But yeah, we'll have to work out some sort of timeline.
Yeah, and the engine can be as low as a 40 or 50 horsepower,
Yeah.
or it can be what? 100?
Well, I mean, yeah, no, it can't be 100.
Oh, I don't know. Okay.
It can go. It can be 40 horsepower up to 60 horsepower.
Okay. And right now it's got a 40 on it.
What's useful load?
Huh?
Useful load on the aircraft?
On that Starlight?
Yeah.
About 320 pounds.
So you could take off if you put like a gallon of gas.
I mean, if you can't get in it, you. Yeah.
Sorry, no, I'm just messing.
Now we're not going to produce it as an ultralight
Yeah.
at all. It'll be a light sport, 100%.
Yeah, I know. Yeah. No, you could take off full fuel. 300 pounds is pretty good.
Yeah.
That'd be good.
I don't know why you don't have somebody engaged getting that thing finished.
I haven't, honestly, I haven't tried. I've been so disengaged with the Odyssey and the Starlight. You know.
Yeah, I just don't know where else you can go and get an aircraft flying.
Yeah.
Right. You had a question? Which one? Okay, well, if you notice, I've made big guesses because I've had aero engineers kind of guess at what we're going to be at with this weight. We think it'll be about 58 miles an hour. Some guys will say 55. I'm not going to have any flaps. Flaps really don't help me, but a couple of miles an hour maybe, and it makes another complexity for me. Might do that later, but we think it'll be around 55 to 58. Mine, in my heavyweight version of it, stalls around 68. And that's, you want to get that as low as you can get it, but when we lose 200 pounds, it's going to change things a lot. So stall speed about 58, top speed around 180. Might go faster, I don't know. That's the aero guys that I was talking to estimated that. Huh? I guess, yeah, that's what I'm planning right now. They say you can go, the best cases are 4 times the stall weight. And that's not very well. Probably have to have a constant speed prop for that, but usually 3. They said 3 to 1 is certainly doable for me. So that's where we are right now. That's why I said 180 full power. Because I have more horsepower and everything's just so light. So I can do that too, or like I said, the problem is with a fixed constant speed prop, it's going to add 10 or 15 grand right there. But it better be a lot of performance for that. So.
But the ground adjustable, you can find the sweet spot.
Sure. Yeah.
I'll tell you what will be a fun project out here for the chapter is I've convinced him to let me make a spring for the airplane, a composite spring for the aircraft.
Tail wheel.
Yeah, for the tail wheel. And so we're going to do it on your press in your little building here, and then once it's cured, then I'll take it over to our ovens and I'll post-cure it up in the 400s. But it'll be super lightweight, and everybody will get to see how it's done and what we're going to do, and participate a little bit in that.
Well, you use terms like wet layup and lock-on and things, and not everybody in here is a plastic airplane builder. So we'd like to see you do a composite 101 class at some point.
That's going to cost $1,298.
That would be very well worth it.
Yeah.
I'd love to do that with y'all.
Yeah.
So, yeah.
Yes, sir. How do I add heat?
How do you add heat
I don't have to
How do you add heat to it?
to cure it.
Well, the resin system that we're using resins have come a long way from where they used to be. So the resin systems that are selected for this one here, at an ambient cure of 80 degrees, we're going to have a TG above 160.
So it's room temp cure versus he's probably thinking autoclave.
Yeah, so like pre-pregs, even pre-pregs now have flow temps in the 80s. They'll start flowing at 80 and then they'll ramp on up to whatever their cure cycle is for their physical property requirements. We do the same thing with these resin systems because it's all epoxy, and I work very closely with our epoxy manufacturers for each specific thing. But a spring, for example, can't be an ambient cure. It has to be an elevated temperature cure part in order to get it to be what it needs to be.
And it's small enough that you have an oven that will fit.
Yeah. So I've been a composite engineer. I was the main composite engineer for Enegra Technologies for over 9 years, and I dealt with all of their clients on a global basis, and we got to work on and solve all these problems like you're talking about. How do we get lower cure temperatures, higher tenacities? How do we get more flex, less? You know what I mean? It's been fun. So I'm lending as much as I can to his project because it mirrors mine, and it's going to help us both.
Yeah, and if you need composite stuff, you got a guy here you can ask questions of. And our tail wheel, this prototype's not going to retract. So I think it'll be, maybe a future one will, but we'll just do what we got to do to get test flying done and make sure it does what it's supposed to do so we can solve some, probably, there will be issues. So you got to solve problems first. Anybody else? Yes, sir? I have emergency gear extension. Now my CAD guy didn't show it, but I have an idea how to do it. And I got my idea straight off of a YouTube video showing this almost exact same system. All I got to do is release the linear motor from the back side because it's holding the gear up. Once you release it, it'll slide. It only has to slide 6 inches because that's the whole stroke of the thing. Once it slides, the weight of the gear is going to want to push that thing down. So it'll slide back
to the end of the track.
And as the gear gets through 45 degrees, that gas strut that's in there is now going to start pushing at 36 foot-pound or inch-pounds to drive it on across the over center. And that exact thing is what I watched on a YouTube video of, and I thought that is slick and super duper easy. All I got to do is release the linear motor, and it hopefully comes down. If it doesn't, well, I don't know. I'll have a new gear for you after you land. Yeah. I've already thought of everything. And the other nice thing, a real Focke-Wulf, you kind of can see it in the picture. There's a little bulge right there forward of the cockpit, right on the wing. That's where the guns were in the real wing. Well, we have that part that we're going to put on the airplane, but that part for us is going to be an access panel. And since the linear motor is going to be behind the strut, the spar, what a great place. You take this panel off that's looks like the gun bulge there, and now you can get in there if something goes wrong or whatever, you need to replace it, whatever. Now you have room to work. This no room to work thing just kills me. And so we want to be able to get to everything that's important, without having the builder having to cut things open. That's insane. So anything else? Yes, sir.
At one time, you were talking about just building the skins.
Yeah.
And re-skinning the existing wood fuselages that were sitting out here that people built. So people would start on their carpenters, they get the woodworking done, they freeze up, and then get the composite work. So you talked about building the skins to put on those.
Yes.
Where did that go?
Well, I've reached out to Don a couple of times, and I haven't gotten any positive feedback from him. But I do think if guys were wanting to build a Focke-Wulf that already had built their wooden frame, we can't build the composites the same way for that, but we could certainly use the molds to create super lightweight skins and a few bulkheads to hold it, and just bond those onto your wooden frame and have the Focke-Wulf.
And you'd lose some weight.
You would lose a bunch of weight in the urethane.
Yeah, and the skin would be exact right.
Yeah.
Ratios of resin,
Yeah.
and it'd be composite.
Yeah.
It'd be the carbon fiber. So you'd probably lose 30, 40, 50 pounds, something like that. So that would be helpful. And you don't have to deal with resins. I think that's what scares everybody. The resins and dealing with the composites, and when you're cutting this stuff, you get dust, all kinds of things from it. So, anyone? Any other questions? Yes, sir. Another one. Yeah. Am I gonna have a what? Is he saying the cannon? Oh yeah, I want the guns. I mean, the guns are a big deal. See these guns? There is no man for sure that doesn't want to have those guns. The guns on the A1 through like 8 versions of them, they were all weren't very muscular. This is really a Focke-Wulf or F8. It was a ground attack one, and it was very muscular on the guns. You can kind of see them kind of sticking up there. I was talking to him about that today. I said, man, I got to have a bomb and I got to have guns. Now that bomb can be is going to be two things. If we get it all mounted up right, and people put these on their war aircraft, but it'll be a travel pod or a 5-gallon gas tank. So you'll go to 500 miles of range. Well, I'm just saying but we just printed that. All you got to do is put a little mechanical fuel pump in there. You could have just a switch in the cockpit that turns that thing on, and you just run it, and all you do is you fill the header tank. Put it to the header tank, and maybe have a low fuel or an empty light that comes on. These are like buying an automotive pump. It already's in there. It's got to be simple, and it's got to be easy to take off. I don't want this thing to be a 5-hour ordeal. If you do it for fuel, if you want to do it for, I got to carry my tent and my supplies up to Oshkosh, then you do it that way too. You just take the nose off and load that baby up, and then you pack it and go, because there's not going to be a lot of room inside, depending on what my weight and balance is.
Easy to get off. It's that bomb release.
Yeah, we'll have a release, emergency release.
That's what I would want.
I would want. Yeah, really. Yeah, I don't know. It'll have a couple of hard points, I'm sure, underneath the middle of the airplane that you'll mount that bomb to. That's it. Once it's on, or the fuel. I haven't figured that. I've drawn it a lot of times. I just haven't quite figured it all out yet. Somebody will figure it out. Anybody else? I get all the questions. It look interesting. There are none. There are none of these. So. No. There are some. Yeah, I know some that are out there, but one of a friend of mine, he had to land his gear up because he sheared his torque tube on. It had it's a worm gear system, and he sheared the torque tube. And I got the video of his landing in the grass. He just walked away, and that airplane will fly again. But I knew that's a failure mode, so I had already thought about that. If I did that, I was going to I always said I'd carry me a wrench in here in case something like that happened. Then I could at least grab that torque tube, and it'd take a while, but I'd just be moving that thing at quarter turn till either I ran out of gas or that gear was down. And but he didn't know that. He said I kept G'ing it up, and I'm like, dude, that was never going to work because it's a worm gear. It's not going to ever let you. But yeah, I've tried to think of a lot of things, and if someone buys this with me, I'll probably have a -1 type thing or an operating manual. I've already talked about prohibited maneuvers. This is just a sport plane that can do basic aerobatics. It's not a Lamschwach machine or anything like that. It's just going to be split S's and rolls and maybe loops and things like that. That's basically all it's going to be designed to do. So, yeah, I told it no spins. I mean, I don't know if it'll spin, but I don't want to test it.
It's got a very big rudder up there.
It's got a big. I've heard it spins and I've heard it comes out, but I don't know. Yes, sir. Oh, we're doing a presentation at the Home Builders building on Wednesday at 11:30, I think. So we'll be up there. You'll see this again. But ask questions like, man, I got to get that thing. Where do I sign up? That's what I want all you guys doing. I'll say I only got 10, first 10, and then you know, and so we're going to try to take a deposit, but it's only going to be an escrow, very low dollar escrow that says I have to give. If I can't deliver you a kit within like 2 years, because I have to fly something, if I can't deliver a kit, then you can have your escrow back.
You're not going to do the PD5.
No, I'm not. I'm trying to, but if I can get enough interest at a low dollar buy-in, then I will. You know, it helps me. So it's really low, and I have to have 2 years, and the worst you can lose is like $50. That's what the escrow company keeps. But you get your money back.
There's a lot of work to be done before we're delivering kits.
Right.
And it is expensive. It's an expensive endeavor, I can assure you.
Yeah, but it would help if I had somebody that wanted one. So that would be helpful. So any other questions? No.
Maybe after this month there'll be somebody.
Yeah. I'd like to put.
Well, we had a lot of people interested last year.
Yeah, if I could have 10 of them just escrowed, it would be a lot easier to start pumping money that way. Because then I know I've got guys that are interested, and if I deliver, they're going to lose their $2,500. You know, if they don't go on, the kit's not going to be that much. So
you really figure out how many hours it's going to take to make all the parts?
We're doing all that so that you don't have to. That's what every single war.
For you.
But thanks for coming out, guys. If you have questions, if you have composite questions, get a hold of Russ. And, or anything you need maybe built or whatever, he loves to build things.
Okay,
Thanks a lot.
give him a hand,
Yeah.
guys.